Welcome to a new video. Measuring voltage is usually simple, but when it comes to measuring current, things get a bit more complicated in terms of wiring and tools. And of course, measuring power become even harder. While working on a project, I ran into a problem. My multimeter could only measure up to 10 amp, which wasn't enough. So I decided to build a better customizable device using current sensor that can handle up to 30 amp. And if you want, you can upgrade it to handle even 200 amp. Let's go step by step and build it together. The component we will use are ESP32 microcontroller or any other microcontroller, current sensor 30 amp specifically, 2 resistors, one 100K, other 10K used for voltage measurement or voltage divider. Screen, I will use 0.96 inch. Feel free to use any available screen in your home, and of course some jumper wire with breadboard. Let's get started with the connection. We will connect the current sensor to one of the analog input on the ESP32. The resistors go on the voltage input to create a voltage divider so the ESP32 can read it safely. The OLED screen connects via I2C, a simple and fast communication protocol, and it's an easy setup as you can see in the screen. Once everything is connected, we go to the Arduino IDE to upload the code. The code is divided in two parts. First, it's read the current and calibrate it, then reads the voltage using voltage divider. Finally, it's calculate the power and show all three values, voltage, ampere, and watt on the OLED screen. And now, we have a simple device that measures voltage, current, and power in real time. You can use it within any household application and monitor its actual consumption. This version handles up to 30 amps and around 35 volts, depending on your voltage divider and current sensor. For more detail about voltage measurement, check out my previous video on the channel. I tested this with my induction heater as a real load, and I will share a full video about it soon, inshallah. It's a simple but very useful project. You will find all project info and links in the video description. Thank you for watching and see you next time. If you are already familiar with this kind of project, then the main part of the video is over for you. But if you are like me, still learning and curious, stick around while I share some of the insight I discovered while building this device. The project can be broken down into a few key stages. 1. Choosing the microcontroller, selecting the sensor, and reading the data, displaying the reading, testing the system, and finally, future upgrade. Microcontroller. Most Arduino board would work just fine. The sensor and code are simple, so nothing fancy is needed. I personally chose the ESP32 because it's compact and includes built-in Bluetooth and Wi-Fi, perfect for future development. Sensor and data reading. Measuring AC current is pretty straightforward using current transformer CTs, but DC current is tricky. CTs will not work because they rely on magnetic field, which are static in DC. That's where Hall effect sensor like ACS712 come in. They can read both AC and DC. These sensors come in different range like 5, 20 and 30 amp. I used the 30 amp module for my project, but remember, higher current range often mean lower accuracy at lower current. If you are working with small loads, I recommend the 5 amp version. One quick tip quietly matters. Some cheap sensors may not handle high current for a long period. Also, when connecting external power to your Arduino, be careful not to plug it into your computer at the same time. I once fried my laptop motherboard this way. Displaying the value, you can use any screen you have available. Just make sure it's connected properly and that your code is set up for the specific display. I used a 0.96 OLED because it's compact and easy to work with. Testing. To test the project, I connected into my induction heater, which drew high current. This was a great way to confirm everything was working accurately. I will make a separate video on that soon. Future upgrade. The ESP32 Wi-Fi and Bluetooth capability open up a lot of options. I am currently working on upgrading the device to display live reading on mobile devices, complete with a chart. And that's it. If you got an experience with this kind of project or tips to share, I would love to hear from you in the comment section. Thank you for watching and see you in the next one.